Analyzing deviations is the fourth step in the controlling process. In general, in most industrial processes or large-scale activities, some deviation from the plan is normal and expected. For example, if you are manufacturing a product, then some wastage or some percentage of defects is expected. The defects or deviations can be due to issues with the raw material, due to errors committed by the workers, or due to the complexity of the manufacturing process. Or they can even be due to some other unavoidable reasons. For example, when some types of computer chips or CPUs are being manufactured, around 5% of them are normally defective and they have to be discarded. So the normal yield is 95%. When the original plans are made to manufacture the computer chips, the ideal plan will be to have 100% yield. But that is not practical and that is not possible. So a defect rate of up to 5% is considered acceptable. The standard yield is set at 95%. If there are several machines that are making these CPUs, then the defect rate of each machine is monitored. If it is within 5%, then the machine is working normally. If the defect rate is more than 5%, then the deviations are analyzed. What is the issue with the machine? What is causing all these extra defects? And what are the corrective and preventive steps to be put in place? Another point to remember here is that even positive or beneficial deviations should be analyzed. For example, if one machine is producing with a consistent defect rate of just 1% as against the normal 5% defect rate, then the reasons should be analyzed. What is going right with this machine? Why is this machine being more efficient? And if the same settings can be replicated with all the other machines, you could probably bring down the defect rate to just 1% across all the machines. The definition of this step, analyzing deviations, is determining acceptable ranges of deviations and focusing on significant deviations in key areas. Now we know how to decide an acceptable or normal range of deviations and how to focus on significant deviations, both positive or beneficial and negative deviations. This definition also talks about focusing on key areas. There are two techniques mentioned here in the textbook. The first is critical point control, which simply says that it is not worth the time and effort of the management to analyze all deviations. You should focus on the key result areas or the important areas which have a significant impact on the process or on the organization. For example, if you have a manufacturing process which is using 10% more electricity than expected and 15% more water than expected, you should probably focus on analyzing and controlling the deviations in the 10% more electricity usage because electricity can be quite costly. And the 15% more water usage may look like a significant deviation, but it is not a priority at this time because the overall impact is negligible, especially if the water is being recycled. In other words, when you are analyzing deviations, focus on those which have a greater impact, which are more critical. The second point is management by exception, which I have previously explained. This technique simply says that you should have some acceptable deviation rates and do a thorough analysis if there is a deviation over or above the acceptable rate. If the deviations are within the acceptable range, then they are treated as low priority issues. By focusing on the critical points or the key result areas and on significant deviations or exceptions, the management can, first of all, save time by focusing only on significant deviations, direct managerial attention to critical issues and improve efficiency, delegate routine problems or simpler issues to subordinates and increase morale by giving them more responsibility, and can also identify critical problems that require immediate attention.